Lesson 4.3, two-digit by two-digit multiplication. For this lesson, depending on where you're at on your multiplication facts, it may be helpful to have a times chart by your side. If you think that could be useful, I encourage you to pause the video and get that out at this moment before you proceed. Now, two-digit by two-digit multiplication is a skill that you learned in 4th grade. And it's possible when you learned it that there were a few different methods given to you as options for using. In my opinion, the traditional method has always been and will always be the best method to use for its accuracy and efficiency. Again, that's my opinion. And so that is going to be the method I use to teach you because that's what I believe in. Now, with that being said, in this first practice problem, there's a method called the place value sections that we will use, and I'll walk you through it. But I don't plan on using this beyond this first practice problem. So that's my disclaimer. The problem given to us is 28 multiplied by 52. I'm going to use rounding to come up with a quick estimate. I can round 28 up to 30. I can round 52 down to 50. And I can solve this using mental math. Count up my zeros. 1, 2. Multiply my non-zero digits. 3 multiplied by 5 is 15. And then add my zeros after. And I get an estimate of 1,500. In the end, we'll check our actual answer to this estimate to determine if it's reasonable or not. Now, looking at this model, it is possible to represent multiplication of two numbers as an area problem, where you showed the longer side as the length of a rectangle, the shorter side as the width of a rectangle, and then you're multiplying length times width to get your area. In this case, notice that 52 has been represented as a line segment broken up into a section of 50 and a section of 2. 28 is represented as a line segment or broken up into a section of 20 and a section of 8. And so if we calculate the area of these 4 sections and add them together, that will give us the total area of the rectangle that's 52 by 28. So that's what we'll do. We'll calculate the area of each of these 4 rectangles, add them together to get the total area of the, I'll call it the outside rectangle. Now, there is a typo. Very important that we correct that right away or it's going to mess up our calculations. This should be a 20 because the short side is 28 and both those sides are equal lengths. Now let's get going. The largest section here is 50 by 20. 50 multiplied by 20. I can count up my zeros. There's 2 of them. I can multiply my non-zeros. 5 times 2 is 10. And then add the 2 zeros to the end of it. Over here, 20 times 2. I've got 1 0. Multiply my non-zeros. 2 times 2 is 4. And then add the 0 to the end to get 40. 50 times 8. I've got 1 0. Multiply my non-zero digits. 5 times 8 is 40. And then add the 0 to the end to get 400. And finally, the smallest section is simply 2 times 8, 16. Now I've calculated the area of these 4 inside rectangles, and I will add them up to get the area of the outside rectangle. To add these numbers together, I will line them up by place value or stack them, as I like to say. Add up the ones column, add up the tens column, add up the hundreds column and the thousands column, and I get an answer of 1,456. This is very much in the ballpark of our estimate, so it sure seems like a reasonable answer. But I'm going to check my work by using the traditional algorithm to solve 28 times 52, because after all, that's the way I want you to be solving these problems, not this place values sections method or any other method. So first, I'm going to line the two digits up by place value. And then my first row, I'm going to cover up the 5 and solve 28 multiplied by 2. 2 times 8 is 16. I'll carry a 1. 2 times 2 is 4 plus the 1 that was carried gets us 5. And then I'm going to cross out this 1 that was carried so it doesn't confuse me when I move on to the next step in the problem, because I don't want to make the mistake of carrying this same number twice. The next row, I'm going to cover this up and solve 28 times 5, but remember to add that 0 placeholder in the second row. Now, 5 times 8 is 40. 0 comes down, 4 gets carried. 5 times 2 is 10, plus the 4 is 14. And bring it on home. The ones column, the tens column, hundreds column, and thousands column, and our answer checks out. Moving on, there's not a whole lot of room to show work, but it's important that you do, so you're going to have to write small. Let's do the evens on the rest of this page. Number 2. First row will be 76 multiplied by 2. 2 times 6 is 12. 1 gets carried. 2 times 7 is 14, plus the 1 is 15. I'm going to cross out the 1 that was carried. I'm going to put my 0 placeholder down. My second row is then going to be 76 times 5. 5 times 6 is 30. The 0 comes down, the 3 gets carried. 5 times 7 is 35, plus the 3 is 38. Add my columns. I get an answer of 3,952. One thing I should have done that I didn't was use rounding to come up with a quick estimate. So I'm going to do that now, even though it would have been more useful to do that before I solved the problem. 76, I could make that 80. 52, I could round that down to 50. Cover up my zeros. 8 times 5 is 40. Now add my 2 zeros. I get an estimate of 4,000, and that sure is close to my actual answer. That gives me extra confidence that I've got a reasonable answer. Let's move on to number 4. Here I'm going to do the estimate first. So 86, I'm going to call that 90, and 14, if I round it down to 10, that feels like too much, but actually I've got a different way of estimating this. I'm going to round 86 up to 100 and then keep 14 as is. Now, cover up my zeros. 14 multiply 1 is 14. Add the 2 zeros. I've got an estimate here of 1,400. And let's get to work. For the first row, I'm going to cover up my 1 and do 86 times 4. 4 times 6 is 24. Carry the 2. 4 times 8 is 32 plus the 2. 34. I'm going to cross out what I carried. I'm going to add my 0 placeholder. And my second row is going to be 86 multiplied by 1. 1 times 6 is 6. 1 times 8 is 8. Add up my columns, 4, 10, 12. I get an answer of 1,204, which is reasonable to my estimate. We have to remember that for the estimate, we did have to round 86 up a fair amount to get to 100. So we expected the estimate to be a little larger than the actual answer, and it was. So still reasonable. Moving on to number 6. A clothing store has 23 child's jumpers. A child's jumper has 14 buttons on it. How many buttons are there on the jumpers altogether? Okay. Multiplication. As expected, 23 multiplied by 14. And I should say that it doesn't matter which factor I put on the top and which I put on the bottom. Out of habit, I tend to put the larger number on top and the smaller on the bottom. But even if I reversed the order of these two, I'd still get the same answer, as long as I solved it accurately. So first row is 23 times 4. 4 times 3 is 12. 2 comes down, 1 gets carried. 4 times 2 is 8, plus the 1 is 9. I'm going to cross out the one that I carried. I'm going to put my 0 placeholder down. And my second row is going to be 23 multiplied by 1. 1 times 3 is 3. 1 times 2 is 2. 2 and 0, 9 and 3 is 12. I get an answer of 322 buttons. Number 8. There are 40 hours in a typical work week for Jason. For every hour he works, Jason earns $30. How much does he earn in a typical work week? And if Jason's earning $30 an hour, that's not too shabby. Good job, Jason. So this is his salary, or the amount he earns per hour. And in a normal work week, he is putting in 40 hours of work. So how much does he earn in a normal or typical work week? We're going to multiply $30 per hour times 40 hours. 40 times 30. And the way this is shaping up actually looks like mental math, doesn't it? Because we can count up or cover up our zeros. There's 2 of them. And then we can multiply our non-zero digits 4 times 3, which is 12. And then add our 2 zeros after to get $1,200 of pay in a normal week.